Hey class, so some of you guys have been asking about question 4 on the workshop, so I thought I would make a video to help you all out with it. So in this problem we have the situation shown in the picture here where we have a rotating rod and a string attached to it that will be moving in uniform circular motion. This is almost like a free preview for what we're going to be doing in lab this week. So let's see what we're asked to determine. We're asked to determine what the tension is in the lower rope. So maybe I'll call this T sub L for the tension in the lower rope. We're given the tension in the upper rope, which I'll call TU up here. We're also given the length L shown in the image as well as the distance D shown in the image. And so from that we can pick out and observe that the radius of rotation can be represented by this R value here, and if we kind of make a triangle we can get some important information that we might need, like the angle that each tension rope makes and so on. So drawing that triangle maybe again down here, this here is the angle theta that the rope makes, and you'll see the same triangle, maybe I'll make it actually look the same triangle for the lower rope as well. Wow, let's just assume that those are the same size. Okay, so we can determine the radius R that we labeled here as well as the angle theta, because R you can clearly see is one of the three sides of a right triangle. So Pythagorean Theorem would tell us that R squared plus D over 2 squared equals L squared. So from that you can get R, and similarly you can see that the sine of that angle theta is just going to be equal to D over 2 divided by L. So you can get the angle and the radius. Cool. But does that help us solve for any of the things we're looking for? Again, we're asked to determine what T of L is, the lower tension. We're also asked to find the net force acting on the ball. I wonder what that's going to be. And lastly, we're asked to find the speed at which the ball is moving. So we'll just call that V. So to do this, we're going to have to do a free body diagram and look at the sum of our forces. So let's start with the free body diagram of our ball. So here's our pink ball. Alright, so what forces do we have acting on it? I'm going to move it down a little. What are our forces? So we have TU, the upper tension, acting at that angle theta that we mentioned earlier. We have the lower tension pulling it in this direction, and as always we have the weight force acting on the object. Okay, so to solve this we should probably define axes. So maybe call this the x direction, and this the y direction. And so again, here is our angle that we know to be theta. This is that same angle theta as well. And so we can set up some of the forces quite easily. If we start some of the forces in the x direction, we know since it's moving under uniform circular motion it's going to be equal to mv squared over r, m times the centripetal acceleration. And so the forces that we have in the positive direction, we have tu in the x direction, so tu cosine theta. Also in that direction we have TL cosine the same theta, and that's all. So that'll be equal to mv squared over r. Nice. And then in the y direction our net force is going to be equal to 0 because it's moving in a horizontal plane, so it's not moving up or down. And so in the y direction we have Tu sine theta, the y component of that upper rope. Then in the negative y direction we have TL sine theta. Again, if we look up at the picture we can see the y component of TL is going to be down, so that's going to be negative. And then we also have the weight force in the downward direction, so minus mg, and those are the only forces, so that's equal to 0. So right away we can observe, looking at our y equation, that we actually know everything in this equation with the exception of the tension in the lower wire. So you can solve for the tension in the lower wire right away. That's part A. Part C, look, here's our velocity over here. You could potentially use the x direction to find the velocity. And then lastly, you're asked to find the net force acting. And that information you should be able to figure out by looking at your sum of your forces here. I'm not going to give you too many more hints on part B because I want you guys to try to solve for that yourselves. So here's our sum of our forces. I hope that helps you guys get started. Let me know if you have additional questions.